Welcome to the AEE Canada East webinar this morning towards an urban sustainable ecosystem. My name is Andrew Penner. I'm the president of the Association of Energy Engineers Canada East chapter, and we're really excited to have this presentation this morning to continue our series of webinars. Before we get going, just a little bit of housekeeping. Chapters like ours really measure their success by the corporate partners we have in the stable, and we've been very lucky over the years to enjoy a pretty strong stable. So we have a great group of sponsors supporting us and making things like these webinars possible. So I'd just like to give a shout out to those. You see them on the screen. A little plug also. We are running towards the end of this year, and we are certainly open and encouraging of other folks to join this group for 2022. So if there's any interest on the line to sponsor a chapter like ours, we'd love to hear from you. You can reach out directly to myself or anyone else on the board. The dollars go towards upkeep of things like this, the webinars, but we also have a pretty strong program of supporting students through the development of endowed scholarships, and that's pretty exciting for us. So if you're interested, please reach out. Of course, we are a chapter of the Association of Energy Engineers. Of course, the association itself is a very large group. It was founded in 1977, so it's been around for a long time. It's not going anywhere. And in fact, over the last number of years, I've watched it grow and almost accelerate in its appeal and in its reach. They talk about being local, global, AEE. So the chapter network really is their local extension, and we are one of over 100, over 90 chapters, but there's at least 6 in Canada, and we're pretty proud of that. So if you're not a member of AEE, we encourage you to be one. There's lots of fantastic resources as part of that organization, journals and other publications. And of course, the network is fantastic. A little bit of housekeeping. We are doing a Zoom webinar, which is kind of funny for us on this end because we don't get any verbal feedback from anybody in the audience. But we do encourage you to ask your questions while the presentation is happening. And you can use that by clicking on the QA button on the Zoom menu that you would have. And you can enter your question, and we'll do our best to ask those questions of the speaker during the presentation. And in that way, we'll create the conversation that we would have otherwise enjoyed if we were all in the same space. So I want to make sure you know that you don't hesitate to make use of it. And of course, so I'll pass the baton off to Mark Bassini, and he'll introduce our speaker for the day for urban sustainable ecosystems. Go ahead, Mark.
Oh, I thought I pressed unmute. Thank you, Andrew. I'm excited to present, to have Mitrex here. I think that's how you say it. It's Emily Reyes from Mitrex. Emily is a presenter on the business development team at Mitrex, where she's responsible for effective communication strategies, ultimately creating awareness about Mitrex globally. Emily has over 6 years of experience in marketing and speaking engagements with a BA in media communications. She's a young professional that's passionate about sustainable energy and combating climate change. And Mitrex is going to be talking about BIPV today, which is a topic that's near and dear to me. That's something I did in my master's. So I'm excited to hear more about it. Go ahead, Emily.
Thank you, Mark. Good morning, everyone. So as Mark just mentioned, my name is Emily. I'm on the business development team at Mitrex. And today I'm going to give you guys a presentation. It's a very high level presentation on who we are, what we're doing, and essentially how we are creating a solution for the construction industry, the construction industry in regards to buildings and basically rethinking building material. As we know, development in North America, and especially in Canada and here in Toronto, where I am right now, the urban landscape is booming. And it's not stopping anytime soon. I'm sure when we're all driving down many of the urban city highways, all we see are cranes in the sky. So without further ado, again, thank you everyone. We will get started. So who is Mitrex? What problem are we solving? And how are we changing the urban landscape when it comes to BIPV moving forward? So that, yes, I just mentioned I am in Toronto, and what we're seeing here is New York City and its skyline. As we know, it's the concrete jungle of the world. And what I want you to do is think about all of these high rises that are soaking up the sun, and take a moment to consider how much electricity each and every one of these buildings are using. Now, when you take a moment to think about it, it's a whole lot. Well, now imagine that each one of these buildings, whether they were retrofitted or any new buildings that are going up, were built with a sustainable material that was generating clean, renewable energy just from their facade. And no one even knew that they were generating energy. Well, it's possible, and that's what we are making happen at Mitrex. Which takes me to our mission statement, which is to be the catalyst that accelerates the adoption of sustainable, energy-generating human-made structures. So here we see a couple of pains and problems. Both are significant and in relation to one another. So the first is in regards to climate change and pollution, and the second is when it comes to construction of high rises and any urban development. So messy construction sites, accidents on site, heavy machinery and heavy and large materials such as precast, and then buildings that eventually start to deteriorate over time from traditional building material that need to be retrofitted over 30 years, for example. So in the last 50 years alone, as we all know, nature has sent us many clear messages, and it's up to us on how we respond to those messages. And that is either the option to ignore nature's guidance at our own risk, or we respect natural laws by adapting to them and changing our ways in almost every single thing that we do. And in our world, it's in construction and development. We must make the right decisions now in order to determine the well-being of our planet. So essentially, to answer nature's calling, Mitrex is a solution to this problem. So as a company, we have a long history of over 25 years in the construction industry, specifically in cladding and in exterior facades. So we have a sister company named Cloudify, which is our cladding company. So our roots are in cladding and construction. And over the last 5 to 6 years, Mitrex has been in the R&D phase where we have been researching and developing how to integrate solar into our proven cladding concept, which is how Mitrex was born. So yes, we've started with buildings, which is the building integrated BIPV. But it's important to note that what I am presenting here today is our long-term vision as a company. So we are a Canadian company. Our head office and our factory is in Etobicoke, so right by the airport in Toronto. And ultimately, this is our way of thinking, and this is our roadmap for the future. So what we plan on doing is integrating solar into every single surface the sun touches. And we start with buildings, which is our solar cladding and our solar glass that I'm going to talk about today. But down the road, this is our roadmap where we are going to integrate solar into roads and sidewalks and highway noise barriers, and also aircrafts and vehicles. Military integrated photovoltaics is something we've already launched as well. So the triangle on the right-hand side here, this is our Mitrex way of thinking. It's our philosophy. So ultimately, every single thing we do is in this triangle. The first thing is when it comes to cost. So what we've done is we've integrated solar into one product. So for example, our solar cladding and our solar glass. Now, often the adoption of solar has been hindered by many things. One of them being cost. So adopting solar is usually quite expensive, whether it's for building owners, developers, or even homeowners. Well, we solve that problem as all of our products are fully integrated. So it's a 2-in-1. You have a building material and you also have a solar panel, for example. So the cost has been lowered because everything is integrated, but we also have 2 purchase options that I will get into later on in the presentation. One of the purchase options, we have significantly lowered the price of the upfront cost of the material. And the other one, it's a little bit of a higher cost, but in turn, the ROI is very higher and significant. Now, the second problem that we have solved in regards to the adoption of solar being hindered or slow is the aesthetics. I'm sure that most of us listening and watching this webinar today would agree that solar panels are not the prettiest. They're normally not a building owner or an architect's first choice when it comes to design. So we've solved that problem by eliminating it completely. So all of our products are completely customizable. They can be any color or any pattern. And in the next couple of slides, you will see better visuals of what I'm talking about in regards to aesthetics and design. And the last thing is the manufacturing process. So the manufacturing can take a very long time, or often solar is imported from globally or overseas. So at our factory here in Toronto, we are actually the biggest BIPV manufacturer in the world, where we can manufacture up to 25,000 square feet of solar integrated material a day. So all that being said, this is part of our philosophy. So our products they're cost effective, there's no design limitation, and they're manufactured quickly. And the reason we're doing all this is for what you're seeing on the left-hand side. So this is our desired city, where essentially we've envisioned every single surface the sun touches being integrated and built with solar technology. So all high rises, whether they be condos or office towers or apartments, stadiums, schools, hospitals, bus shelters, etc., they can all be built with a sustainable material that is generating clean, renewable energy. This is what the BIPV system itself actually looks like. I know you guys mostly are all engineers, so I'm sure you'll get very technical. This is more of a high level overview. So essentially all of the wiring in regards to the panels, whether they may be the solar glass, the windows, or the railings, or the cladding, all of the wiring is safely and visibly incorporated behind the panels, and they're all installed in a way where they're filtered in exactly the way the electrical is installed into the building. Now, part of our turnkey service that I also will get into throughout this presentation is that we are providing a turnkey service. So we are not just selling the product, but we provide installation services as well with every single project that we work on, where we handle the electrical and the installation of the cladding and the solar glass as well. But essentially, in regards to a question we always get is, how much room do we actually need in a building? The answer is not much at all. So the same electrical room that would be in a condo, for example, we just take up a small component in that room for the solar energy. Now, this is a breakdown or an explosion, as we like to call it, of our two core products and what they are made of and how they're put together. So we have our solar glass, which is also our solar railing, and our solar cladding. So the solar glass is made of 2 layers of tempered glass on the front and the back, and the solar technology is sandwiched in between the layers of the glass. Now, the solar technology, the solar glass can be opaque. If it's a spandrel glass, it can be semi-opaque, or it can be semi-transparent. It really depends on how we are integrating these solar cells into the glass. So for example, if it's opaque or semi-opaque, we're using the monocrystalline solar cells and integrating them into the glass, or it can be transparent or vision glass if we're using thin film solar technology. Now the cladding, which is our core product here at Mitrex. So our solar cladding is made of 3 integral layers. So the front layer is the customizable facing material, which is a tempered glass. Now behind the tempered glass is the solar cells, and the backing is an aluminum honeycomb backing. So the customizable facing material, the front layer, which is the tempered glass, there are several coatings on top of the glass that make them self-sufficient and self-cleaning. So there's an anti-UV stable coating, which helps the solar cells absorb as much sunlight as possible, increasing the efficiency of the panel. And this coating also allows the solar cladding to look the same as it does in year 1 as it will in year 30. So it will always look the same. The color won't change or be hindered by sun over 30 years or rain or weather, etc. There's also an anti-soiling coating on top of the glass, which makes it self-cleaning, which means it won't be pitted by elements such as rain or hail, for example. And because it's self-cleaning, there's absolutely no maintenance on the product. So the buildings won't need to be cleaned throughout the years or throughout the seasons. They clean themselves from the wind and the rain. Now the backing is an aluminum honeycomb backing. So the aluminum honeycomb backing is great for a few things. One is it's extremely durable and it's lightweight. So it allows for easy installation, which means there's no need for any cranes on a job site. It can be shipped fairly easily because it's lightweight. The question we always get is, what's the weight per square foot? It's about 4 pounds per square foot. So it's great for installation, as we don't need any heavy machineries, and it's also good for shipping and very fast and easy installation. So for typical cladding or traditional material like brick or concrete, Oftentimes the installation can take a long time. We're in and out of a job site much quicker than traditional materials as well. So what you're seeing here is going back to what I was saying in regards to the aesthetics and the look of the panels. So these are a few of our color and swatches that we have on our library, available on our website as well. But it's important to note that the colors and patterns that you're seeing here, we are not limited to that at all. It's completely customizable. So whether your client has a custom color or logo they want to use, we can do that. If they have a specific marble they want to use, we can do that as well. So basically, we can now build buildings with a solar cladding that can be any color, any pattern, and does not look like a solar panel at all. And anybody could be walking by it or looking at it and not know it's generating energy. Now, with that said, a question I almost always get is, does the color or pattern affect the power output? The answer is yes. So typically speaking, the more simple the color and the darker the color, so anything that is a dark black or brown or gray, so any of the wood grains here, or any stone that's a darker color, any of the marbles that are a darker color, those are best for power output. So typically they range from about 15 to 17 watts per square foot, but on average, depending on color, the power is about 10 to 17 watts per square foot. So our typical panel size is 1 by 2 meters, and a darker color would typically be about 300 watts per panel. In regards to the installation, so there is nothing unique in regards to installation. What I mean by that is it's very simple and straightforward. Any trade that knows or does install regular cladding, our cladding is installed the exact same way. So there's many installation methods, for example, anchor plate systems, E-clip attachments, or interlocking channels. These are for the standard installation methods. But again, our team does handle this as a full turnkey service. This is another visual of our solar glass to give you an idea and an example. So these are a few of the color options and their transparency levels. And again, yes, the transparency level does affect the power output of the glass. Typically with glass, the power output is a lot less than a solar panel. It's about 5 watts to 10 watts per square foot. But with that being said, what we're doing is we're competing with zero. We're competing with the glass that does nothing. And just like the cladding, the solar glass and the solar rail, there are many standard installation options, nothing unique. It's all standard across the board in regards to how it's installed. Now this here is a rendering of a project that we're actually currently working on in Ontario. And this really paints a picture to show you how all 3 solar solutions are applied onto a building. So as you see here, all of this white that looks like it's a stone, it's actually our solar cladding. And then we've also integrated our solar railing and our solar windows onto the project. Now, another common question we almost always get is, do you only put the BIPV on one wall, or the south wall specifically? The answer is no. We build and integrate the BIPV on all 4 vertical walls. Now, the reason being, as part of our philosophy, is every single surface the sun touches can and will create solar energy. So yes, the south side almost always will create the most energy, but the north side will still create energy as well. With that being said, it's about 30% less than the south side.
Emily, I don't know if I heard this right, but I heard you mention with darker colors, you can expect around 15 watts per square foot. But then I thought on the next slide, when you were talking about how these panels don't generate as much energy, you said 5 to 10 watts per square foot. So
that's that's for the glass.
Oh, okay.
Yeah, so the cladding will generate, again, depending on color and design, anywhere from 10 to 17 watts per square foot for the cladding. The glass is about 5 to 10 watts per square foot, depending on if it's opaque, semi-opaque, or transparent.
So the thin film technology is what generates less per square foot.
Yes,
okay.
exactly.
Yeah. Thanks.
No problem. So this is where we talk about our solar as a service and our turnkey services. So as part of our vision to make it easier for architects or engineers, consultants, developers, building owners to adopt solar technology into their buildings, a big part of what we're doing is offering solar as a service. So instead of just selling the product and having them figure it out, we really are there every step of the way. And part of our turnkey service includes, the first step is usually receiving a drawing for a project. So for example, if any of you have a project that you're working with where you would like an analysis done, that's really where we start. And an analysis is completely free. And what an analysis includes, it's essentially an estimation where we need the architectural or the structural drawings, and we take a look at the building to determine where the BIPV makes sense, whether it's if you're looking at stone or brick or precast or even cladding, where we can integrate the solar cladding, which is essentially most times the entire building, and the spandrel glass or the solar glass. And what an analysis includes is all of the building material that we would for the project, the cost, as well as the energy output. So what your expected kilowatt system would be for the entire building. Now, in this analysis, we take into consideration geographical location. So where the project is, whether it's in Canada or whether it's in Dubai, that makes a huge difference in regards to hours of sunlight. We also take into consideration shading. So existing shading or future shading with trees or any buildings that are going to be going up. These are all things that are part of the analysis. So cost, building material, and energy that the building will be expected to produce, as well as if it's in Canada, we can also include the tax incentives, which I will get into shortly as well as what the expected ROI or the energy revenue is from the BIPV, from the solar energy that's will produce for the building. So that's really step one. And then throughout, once a project moves forward, it's really about scheduling and planning. So our team works closely with the architects and the designers for shop drawings, installation manuals, installation methods. And then following that, down the road, we're involved right up until the installation, as well as the maintenance of the building. So installation of the product, of the electrical, and then maintenance over 30 years as well.
And Emily, do you get into the logistics of like how wiring is routed and stuff like that in this presentation, or?
No, so not in this presentation. This is really a high level version of the presentation. But in regards to wiring, I'm not sure if you have any questions specifically, but basically the way the wiring works is behind each panel, there's 2 cables and wires that come out, and they're all connected, and the entire system is monitored with inverters. And the way the wiring is connected, it's all behind the panels, and it connects into the building the same way the electrical would. It's just a different set of wires.
So if you were, does anyone just, let's say you're replacing windows in your building anyway, does it make sense to look at this technology just on a individual window replacement basis?
Are you talking in terms of, let's say, a retrofit that needed the windows replaced?
They've not cladding, but just the windows themselves to go with a semi-transparent, solution, but to generate a bit of power, because then you're just looking, because I know we talked about how the incremental cost approach is usually what makes the most sense, but I'm wondering if you ever get into windows or if it's always just cladding and railings and things like that.
Good question. So yes, we do get into windows. However, our bread and butter is the cladding, as well as the railing or the solar glass or the spandrel. So for solar glass and windows, so windows and spandrel, yes, they're 2 different things, but essentially they're both solar glass. So with clients that we're working with now, we're actually working with them and their current window supplier, because our expertise is not in windows, and it's not in curtain wall systems or anything like that. So oftentimes what we are doing is we're working with the window supplier, and we are providing them with the solar glass, whether it is spandrel glass or whether it is vision glass for the windows of the building. I will say where we are right now, we probably wouldn't just provide the product or even a quote for solar windows, as it's not our expertise. It's usually an added product to the solar cladding or the spandrel glass or the railings. Does that make sense?
Yeah. Okay. Thank you.
No problem. All right, so now we're getting into our ownership options as well as costs. So here first I'll talk about our 2 ownership options, and then I'm going to get into a case study that really will probably paint a better picture for you and get into to average cost as well. So we are a Canadian company, and we do have 2 purchase options primarily for the Canadian market right now. So the first one is MPA, which is our Mitrex Power Agreement. With MPA, what we are doing is we are selling the product at a lower market price in comparison to traditional material. And by selling the product at a lower market price, Mitrex owns the energy that's being generated from the building. And we make our money or we make our investment back over the next 30 years from the energy that's being generated from the building. Now, the MPA purchase model includes all of our turnkey services as well as maintenance over 30 years. So essentially what we are doing also is by owning the energy that's being generated from the building, we still share it back with the building owner. So if electricity, for example, in Toronto, it's 15 cents a kilowatt, we would be selling it to the building owner at 12 cents a kilowatt. So 3 cents less, whatever the current cost of the grid is. Now, alternatively speaking, we have our direct purchase agreement or DPA. So the DPA, we are selling the product at a higher market price. However, in turn, the building owner has full ownership of all of the generated electricity from the building, which results in a very high ROI. All of our turnkey services are still included with DPA. The only thing that is not included is our maintenance over 30 years. Maintenance over 30 years, as I was mentioning earlier, there is little to no maintenance on the product as they don't need to be cleaned or anything like that. What maintenance I'm talking about really is if any of the panels need to be replaced or need to be monitored quite frequently. With MPA, we handle all of that. We're always monitoring the system as we're responsible for the energy that's being generated, as that's how we make our money back. And we will continuously monitor the system over 30 years and replace any panels. Now with DPA, we will still replace the panels we will replace the material free of cost. However, we don't monitor the system, and the building owner would need to pay for the labor to replace any panels. With that being said, I should also talk about our warranty right now as well. So the warranty on our product is the exact same as traditional solar panels, which is 25 years. And at year 25, the panel should still be generating at 83.1% efficiency. So here's the case study that will follow through with what I was just saying on the ownership options. So typically speaking, this is for a 100,000 square foot apartment building in Ontario. So the client was looking at using traditional cladding for the project, where they were going to spend $6.5 million or $65 per square foot on the cladding of their building. Now, so with MPA, what the cost is, it's $45 per square foot, which means we have lowered their upfront cost that they need to spend regardless on their exterior facade by $2 million. So instead of paying $65 per square foot for traditional cladding that does nothing, they had the option to pay $45 for a solar cladding. Now, because Mitrex owns the energy that's being generated over 30 years, this client is actually saving $720,000 on electricity over that 30-year period from our revenue sharing, because we are selling the electricity back to them at a lower cost than whatever they're paying locally. And in this case, the numbers are 12 cents a kilowatt versus 15 cents a kilowatt. So what that means is the payback period is actually 0 because we are lowering their upfront investment that they would have had to spend regardless on their facade. Now, the DPA purchase option, instead of paying $65 for their facade, the cost is $80 per square foot. So this building owner had the option to invest $1.5 million into the solar of their facade. So instead of paying $6.5 million, they're actually paying $8 million total for their exterior facade. However, over a 30-year period, this building owner would make about $4.8 million in electricity revenue just from their facade, which makes the payback period of the investment of solar 9 years. Now, I'm not sure if anyone has questions on this slide. Yes, Mark.
Is just curious, what kind of cladding is the base case, like that $6.5 million solution?
So it would be a traditional cladding with like a stone or a limestone. So that's, for example, with our sister company Cladify, that's about the average cost of cladding on the market in Canada.
Okay. Yeah, so it's not, I'm just thinking like life cycle, because like would you expect the Mitrex solution to last as long as a stone facade versus like a glass curtain wall type of facade? Like, are we comparing apples to apples here, I guess, or?
Yes, most definitely. And thank you for asking that question. Yes, we are comparing apples to apples. So because the cladding, our solar cladding is also a tempered glass, it's expected to last the exact same as normal glass would on a facade. So because we aren't there yet, I mean, we're not at year 30. We don't know until we get there. But based on our R&D, and because it is a tempered glass, it will last the same 30 years, if not a lot longer than traditional material, such as, for example, it would last longer than crick, stone, or precast.
Okay, thank you.
You're welcome. Are there any other questions for this slide?
There's one in the chat. Yeah, it says, are most of your projects with new construction or retrofit renovations?
I love this question. Thank you. I apologize. I should have mentioned this a lot earlier on in the presentation. It is both. So Mitrex is great for retrofits because there's the option to overclad or reclad the building. And the next slide, we're actually going to get into tax incentives. And when in Canada right now, especially, and in the US, but in Canada, there are many incentives available to retrofit a building with BIPV, or something that is sustainable and better for the environment. Now, when it comes to new builds, I would say the projects that we are in our estimating system right now and in our RFQ line, it's mixed 50% retrofit, 50% new build. So it is for both. Now, a question that a client actually asked me the other day is, does it make sense to do a proposal for Mitrex on a building that's only been up for 10 years? If the building owner loves the idea and they want to start, adding sustainable goals to their marketing and just make their building all around energy efficient and more sustainable. Typically speaking, no, it doesn't necessarily make sense financially for a building owner to apply Mitrex to their building if it's not needed, if the retrofit isn't necessary yet, or if it's not a new build. So retrofits and new builds are definitely our core client base. Okay, so picking up where in regards to what I was just talking about in regards to tax incentives. So right now in Canada, like I was mentioning, there are many tax incentives available to building owners that are using BIPV, solar, or anything that is generating energy. So obviously solar. With that being said, any building that is being built to own, so if it's a commercial building, an office tower, an apartment, basically if it's not a condo, there are many tax incentives available for building owners. And with Mitrex, with the accelerated capital cost allowance, our material can actually be written off in the first year or the first 3 years. And we include these potential savings and tax incentives when we are doing a proposal for a client. So it would show you what the actual cost is for our system, and then what the savings are from the energy revenue over 30 years, and what the savings are with the tax incentives in year one over the first 3 years. All right, I'm closing off our presentation shortly. Everyone here, I'm sure, is very keen on, as we're all here in this webinar, very keen on energy and sustainability and what we can do for our projects moving forward and how we can basically make a significant impact on the world moving forward, especially for the next generations to come. So what this slide is demonstrating is the significant environmental impact of building developments with this BIPV and sustainable material. So on the top, what we're seeing here is from one building over a 30-year period that is built with Mitrex cladding and solar glass and solar railings. It's actually equivalent to electricity for 1,700 homes, 6 million trees planted, and 2,000 cars off the road. And then we multiply that by 50 buildings. The numbers on the bottom illustrate what the impact is of that. So 50 buildings constructed by 2050 were built with our material. It's equivalent to 5 billion trees planted and 1.6 million cars off the road. And to close off the presentation, as I mentioned, actually, I don't even think I mentioned this properly in the beginning, but even though we've been in R&D for the past couple of years, our company is still heavily invested into R&D. We have our own R&D team at the office. We have our own lab here in our factory. And what we are doing is we're constantly pushing the envelope and integrating solar into new products. So this is currently what we have in our catalog, which is our solar cladding, our solar windows, our solar railing, and our solar glass, which I talked about today. And then we also have products for our B2C market, which is our solar roof and our solar siding, which is for, as I mentioned, it's for B2C. So all these products are launched on our website right now, and they'll be shipping out in January. But what that means is we've created an aesthetically pleasing product for customers and homeowners as well, where they actually don't need to just have the option of traditional solar panels, which in my opinion and most are quite ugly. They can now have solar panels that blend into their existing roof. We have many different color options available for siding and for roof structures as well. Yes, Mark,
We
question?
do have one question here. It says, I guess, is it right to assume that solar or glass or railings in a renovation could be relatively easy? I think they probably mean new construction, because then they said, but what are the challenges of installing solar cladding on an existing building? So I think the question here is it easier in new construction versus renovation, and what's the difference in payback between a retrofit versus new build?
Let me try to answer the question in two parts. So no, the answer is no. It's still great for retrofit. So with retrofits, the option is to have it overcladded on the building or recladded. When we're recladding the building, it does cost a lot more, of course, because the building owner needs to hire a team to take down the existing facade. Now, the payback period actually still, it ends up being the same, because with a retrofit, the building owner still needs to make an investment on finishing the facade as a retrofit. Now, with a new build, normally there is cost available or an investment available on the new builds, because they have all their finances in order and they understand what they need to spend on the facade. But with the retrofit, it still ends up being the same. So for example, we're actually working on a retrofit in Ottawa where the client was going to pay $60 per square foot on it was a brick system. And our cost ended up being $58 per square foot. So we came in under what they were spec'd for the material they were going to use anyways. And our cost includes the installation. So all of our costs that I was mentioning earlier, that includes the full turnkey service. So that's for the material and the install, and the full turnkey service. So no, it's the product is good for both retrofits and new developments. And what we always do too is when we're doing the analysis, we'll ask the client what their budget is, what other material are they typically speccing. For some clients, it doesn't make sense. If they want to use an AEECE, the cost is going to be a lot less and a lot lower. So Mitrex might not make sense for that particular project.
Hey, Emily, I've got a question for you. So,
Yeah.
this, I mean, I think building integrated PV is is a fantastic product, and I'd like to see it adopted more frequently and more broadly. Do you find the folks that are coming to you in either retrofit or new construction, like is this type of technology part of a larger suite of measures that they're looking to implement, or are you normally seeing people coming with just a cladding project? I know you won't deliver the rest, but like you must have some insight into what they're doing for their buildings.
Sorry, can you elaborate a little bit? Do you mean if they're also looking at, let's say, thermal, and if they're also looking at so they're heating and then also water?
Yeah, because a little bit of background, like I work for BGIS and we manage portfolios of buildings, and we've done over 100 what we call carbon neutral studies in these assets to understand what the path to zero carbon is for each of those buildings. And
Right.
Often envelope comes into play, especially when you're trying to push all the way up to the zero, right? It might be easy to get to 70 or 80% with the internal systems and loads, but then you got to do something with your envelope. And so we end up finding that the envelope only really makes sense when it's bundled with other things. I'm just curious if you're finding the same, more broadly throughout the marketplace when people come to you for your product.
Yes and no. So we have I would say a broad spectrum of clients that we speak to. So oftentimes it's the building owners that come to us first. Sometimes it's the architects that come to us first, or the engineers or a consultant. And it really depends on also who is coming to us initially, because everybody has all these different types of accounts have different goals they're trying to reach. With the building owner, for them, it's all about cost. For the architect, it's all about design. For the consultants and engineers, it's all about the achieving a net zero, right? So we have some clients that do come to us because they have very significant sustainability goals. They want to be green buildings. They want to achieve green building standards. They want to have LEED points. They want to achieve a net zero. So yes, there are some clients that come to us, and oftentimes they're referrals from other, let's say, thermal companies that are working on the thermal for the building. They will refer us to the project, and they'll connect us with them and say, how do we work on this together to achieve a net zero? Then we have other clients who come to us with no sustainability goals in mind whatsoever. They are just intrigued by the product, intrigued by the technology, and want to be a leader in adapting the BIPV for their buildings. And then they realize, you know what, this is great. We should have sustainability at the forefront of our goal for this project and upcoming projects. And then we have clients who are in between, who do sustainability goals, love the product, and for them it's enough to just have solar cladding on the building, etc. Now, there was something I wanted to answer in your question as well that I'm forgetting right now. So just give me a moment. Oh, okay. In terms of people coming to us for just cladding. So it's important to note that all buildings need to be finished with something, whether it is traditional cladding or traditional stone, brick, precast, etc. All of these building owners and architects, etc., need to finish the facade with something. They need to invest in something, some type of material. And that's really what we're competing with. Our competitors are traditional materials that are doing zero, that there is an investment on them, that is generating no energy, that probably isn't good for the environment because it can't be broken down in the future. So really that's what we are competing with, is we are competing with products that are traditional, that are all that we've known for the past 100 years and what we've been building with. And this is an alternative solution that costs the same or less and generates energy. So really, we are seeing a lot of projects come to us now to be spec'd in general, just because they need to finish their facade, or we're having clients come to us specifically for sustainability goals and want to integrate BIPV. Does that answer your question?
Yeah, no, it certainly does. I mean, I think what you're really relying on and tugging on is that incremental, right? A relatively small incremental investment to achieve something greater, which is great. Exactly. I wonder if, early on, and maybe you don't have this information, but early on, would you have found that the people that were calling you were, quote unquote, the altruists, the people that were most concerned about doing something good, even if it wasn't necessarily going to be a direct, financial benefit to them? Is that the profile of the person who came to you, or the company or the owner that came to you at the beginning, or did that never really filter out that way?
No, you know what? No. So Mitrex was launched early 2020. So we're going on 2 years of being on the market, with our website just launching last fall. So for us, we're still in the early stages of fine-tuning our client base. So right now, really, it's very broad. I can't yet put, and no one at our company can put our core clients into a category, because it's very broad. Who we mostly speak with on the day-to-day is architects and building owners. Those are our funnel of clients right now. And separate to that, as I was saying, we have consultants, engineers, and also even a lot of installers as well. And right now, the feedback, it varies. And really what we are achieving is going after those early adopters who want to be the first to integrate BIPV into their buildings and the cladding. And some of those early adopters that we're speaking with and are going to be starting construction over the next couple of months, it ranges. Like, it's crazy. None of them are the same. I can't really funnel them yet. I think in the next couple of years we'll be able to put them into different types of categories and say, you know, strictly the clients that have sustainability goals, they are core clients, or those that are very focused on cost and don't even care about the sustainability. They just want to keep their costs down. Those, I would say, are the two categories that we mostly are dealing with right now.
That's cool. Awesome. I've got another question that's popped into my mind. It's a little bit more technical. So I think earlier on when you were talking about the different purchasing strategies with respect to the energy that would be generated by these panels, and it occurs to me that you're probably generating less energy than typically the building consumes. So there really is no grid connection. That's correct?
Yes, that's correct. We would never recommend to connect to the grid. And we also don't include batteries in our quotes or recommend to use batteries to back up any of the energy. The reason being is because all of the solar energy will be utilized throughout the day. And it's about 30% of the building's need. So for example, one of the clients we're working with right now, it's a retirement facility. The building owner plans on using the solar energy for all their common areas. So the lobby, all the lights throughout the peak hours of the day, they're only using it for the common areas, and then each of the rooms still need to be connected to the grid. So no, we're not able to take any building off grid entirely, not for the next couple of years. With our R&D and just knowing what's on the market, we predict that in the next couple of years, there will be panels on the market and solar cells strong enough or that can produce a lot more energy than what's on the market right now. But right now, as a rule of thumb, it's about 30% of a building's electricity need.
Okay. I'm curious, just out of curiosity, have you guys done any projects on passive house standard buildings? You know, those buildings are really pushing the load envelope, and therefore perhaps your 30% might be edging up to 40 or 50, maybe. I don't know.
Yeah, I personally have not worked on any passive housing projects, but I know a few of my team members have. And there's many challenges in working with passive house. And from conversations I've had with my team, I really, from what I remember, it's because there are many different restrictions and goals they need to reach. And there's so many different specifications that need to be met with so many different material suppliers and the way everything's connected that I know I'm not going to say this well because I'm not actually working on the project, so I don't know the ins and outs of it, but solar cladding for those projects might not be feasible, and we're trying to figure out a way to make it feasible. But because there's so many specifications on building material and energy for both heat, water, and all that, it's seeming to be a challenge for us right now.
Okay. Well, that's a fair answer. You haven't been around for overly long, right? So there's lots to evolve with the product, which is fine.
Yeah. So essentially, for passive house, they're not our core clients right now. It really is new builds and retrofits.
Okay. So I have one more question. I don't see that there's any more that have popped up in our Q&A box. So it has to do with the market that you're serving. So this chapter of the Association of Energy Engineers covers the eastern part of Canada. So, you know, kind of like Kingston in Ontario all the way through the Atlantic Canadian provinces. But I do know that we had some folks sign up for this webinar from further abroad, so Alberta and some in the States. So the question that I have is, how widely distributable is your product?
So our core focus right now is North America. So we have projects, actually we have many projects in Alberta because the hours of sunlight there are great and solar is huge in the province right now. So our market focus for our first couple of years is North America. So across Canada and the US. We're also working on a few projects that we've quoted on for spandrel glass and cladding in the States, particularly in California. So we can work on any project in North America. But with that said, our phase 2 of our strategy is really expanding globally, especially in the Middle East and then Asia and Europe as well. So in terms of cost, so for Canada, costs are basically what the numbers I said in our presentation are average prices, but of course it varies project to project depending on how much energy will the building produce, the color of the panels, what the order is, what the quantity is, etc. But for MPA, it's about $45 per square foot, full turnkey, so product and install. And with DPA, it's about $80 per square foot, supply and install. In the States, we can offer MPA as well. However, it varies state to state as there's many different laws in each state. So it is project to project basis, but we can also do supply only in the US regions and send a supervisor for installation or provide our own installation team. And supply only it's $20 to $25 USD per square foot for the solar cladding.
Awesome. Excellent. So I don't see any more questions. I don't know, Mark, if anything else kind of popped into your mind as we were having this conversation.
I guess the only thing I would say, just I know you didn't mention incentives in Ontario because I don't think there are any anymore, but in some other provinces there might be. Like I'm doing work in Nova Scotia, they pay 10 cents per kilowatt hour for I guess the estimated production that you would get in 1 year. So there would be a bit of upfront, a bit of an upfront grant or incentive there. I'm not sure about other provinces, but I'm guessing it would qualify for that because it is, in the end, it's a solar product, right? So
yeah. So Mark, whenever our sales consultants are working with a client on a project, these are all the questions that they ask and take into consideration. So with any project that is in a different province, we actually do have we have a full understanding of all the incentives that are available specifically for Mitrex across the province and in the US states as well. So our sales consultants work closely with the client in those regions to ensure that they have an understanding of not only the cost of our system, but then also, of course, the tax incentives that they can apply to the project, as it's really just the cherry on top of having a system that is affordable, beautiful, and sustainable.
agreed. Thank you.
You're welcome.
All right. So Emily, do you have any contact information that you can flash on the screen so the folks that have been watching are interested in reaching out, they can find you?
I only have here, this is our office contact info. This actually goes to my team info at Mitrex, so all of the inquiries would come to me. But my email is, I'm pretty sure you guys can see the spelling of my name, but it's my first name .r@mitrex.com. So EMELIE.r@mitrex.com. But if you email info, I will get that as well.
Oh, that's excellent. Well, thanks again for coming out this morning and sharing your product story with us. I think you've probably inspired a few people to look a little more closely at building integrated PV. I know historically when we looked at it, dating back a few years, it was perhaps not the slam dunk that we wanted it to be, but it looks like you've done a good job and pushed the R&D envelope a little bit, and you've also created a product that looks real nice. It blends really well into the urban architectural infrastructure. So thanks for coming out and sharing your story.
No, thank you so much for giving me the opportunity to. I really hope that everyone does now have a better understanding of this solution. And going off of what Andrew just said, it's true. Over the past couple of years, BIPV is not a new technology. We're not the first company to create a product where we're not going to be the last either. But we are really proud of what we have created. We are first to market to integrate solar into cladding. So we're very proud of that, and we're proudly Canadian. But if there's anything I want you guys to walk away from, is that there is a building material now that is fully integrated with solar. It looks beautiful. It costs the same or less than traditional material. It's easy to install. and it's right in your backyard in Canada. For those of you that are in Canada and the US, we're just across the border. So thank you so much again for this opportunity. And I look forward to receiving any questions or projects or even separate meetings after this as well. If you want to learn more, or have me do the same presentation for your team. So thank you.
That's great. Thanks a lot. So before we wrap up entirely, I was just going to splash one more thing across the screen here. We have one more webinar established or set up for this calendar year. And so Siemens is going to speak to us about air sampling for ventilation management. And it's really they're going to be talking about their application of the Air Acuity product line, which is AQ Guard by Siemens. So if you're interested in understanding a little bit more about air sampling for ventilation management, please look out for our advertisements for our November webinar. Thanks a lot for joining us. If you have any questions, please feel free to reach out to myself or to Mark. You can get us through our website or through LinkedIn, and we look forward to seeing you at the next webinar. Stay safe and stay healthy, folks. Cheers.